Well, ladies and gentlemen, dear rector of the university, when I thought what topic would be of interest to you for this lecture I was asked to present today, I concluded it would be not the best to talk about the sciences. I did very many years ago. I thought it would be much better to talk about a topic which is very close to my heart as president of the Max Planck Society and which is really a hot topic, I have to say, in science policy these days. So the topic of my talk is I want to talk about the relation between scientific excellence in a globalized world, its relation to international collaboration in general, but also on the pros and cons this collaboration may have for the individual partners. And let me start with a very simple picture. Or let me say with the first question, then comes a picture. How important is really scientific collaboration for solving big challenges we have today? And I would like to start with a picture which we all know, and this is a virus we all know which has caused the COVID disease. And here in that picture it looks really nice, I have to say. It's a beautiful art picture, but it's a real electron microscopic study of that virus. And it looks, as I said, a bit nice. In reality, it was a very nasty virus. It has caused very severe diseases. It has spread in extremely short time around the globe, and it has indeed caused severe illness and also killed millions of people around the world. It has stopped traveling and personal exchange for 2 years. It has caused immense damage to industry and economy, but it has never stopped scientific collaboration. And here you see a picture which I found quite amazing. It shows you the kind of collaboration which has, let me say, started from the very beginning on. Let me see if I can see this here. Here we are. From the very beginning on, so first months in 2020, and then going on with time. Indeed, the pandemic has steered up a collaboration between scientists all over the world in extreme manner. The first genetic analysis was immediately published, as well as details of the virus structures we had shown you before, and the first trials also to fight the virus by chemical intervention. The number of coronavirus publications has had a great boom. It started with very few papers, a couple of thousand papers in January and March and April, and then ended up with more than 100,000 papers at the end of October. By the way, now there has just been published a paper with 15,000 collaborators just recently on the outcome of the corona pandemic and the problems it had caused in medicine. This is the paper which has the highest number of authors ever, I have to say. The second one is with 5,000 authors, Higgs boson, so 15,000 tells you a lot on this kind of collaboration. Now, where do these papers originate from? You can see this, I hope you can read this. I think these are all the sites in the world which are active in science, but in particular the papers have originated in countries which are mostly affected, China for example, but also the US, Italy, France, Germany, in Europe, where the virus has caused lots of damage. The result of all the scientific interaction is obvious. We are much better off today. We have highly effective vaccines. Humans have proven that scientific insight is of central importance, in fact, for solving big challenges which we have. But that's not all. We have many more challenges, like, for example, global warming, sustainable energy production, aging societies, pandemics, etc., etc., etc. Probably one of the most pressing ones these days is global warming. I think that affects all of us. And 2 years ago, the Nobel Prize was given, among others, to Klaus Hasselmann, which is a retired director of our Max Planck Institute for Meteorology in Hamburg. And he was the very first in a landmark paper to be able to differentiate between climate change as such and the fluctuating weather conditions on the other side. And he was also the first to show human fingerprint on global warming. That's what you can see, in fact, here. This is, let me say, the measured data on temperature rays, and he was able to distinguish, let me say, between natural fluctuations, like, let me say, volcanic eruptions, and what humans are really doing. This paper, by the way, is made up of very deep math, and statistics reach very hard to understand, and it was very much ahead of its time. The paper was published more than 40 years ago, was the very first one, and it took decades until the public really took notice on the dramatic global warming which we experience these days. It's also very obvious. We have now to realize dramatic scenarios which are lying ahead of us. The 1.5 degree temperature raise is already more or less being done. So I don't think we can stop at that point. And the temperature ranges which are lying ahead of us are really dramatic. If you take into consideration that for the last 15,000 years, the climate was extremely stable, and that was, of course, for the benefit of mankind as such. Today's temperature increase, in fact, mimics earlier times in Earth's history, which have caused dramatic changes in the respective animal population. And we can only hope that that will not happen in future again. The ultimate goal today is, of course, to deal with this issue. And how we do so in general, well, I think scientists and industry have come up with very detailed concepts in how we can deal with this issue as such. I don't want to go in any details here, but it's generally believed that we have to take into account a local electricity grid, which let me say is based on, let me say, for example, solar panels or wind turbines, etc. But that is only good, let me say, if you consume the electricity being produced immediately on the same site or in the same country or so. That will not be enough in general, and so there's also the idea that a global hydrogen grid has to be established, which allows them to transport energy over long distances, which allows you to store energy and also to supply hydrogen as an important component for chemical industry as such. The hydrogen economy, which is being discussed these days, has different stages as being seen here. First of all, hydrogen, of course, has to be produced, and that's more or less an electrochemical process. So electrochemistry is getting important, very important here. It has to be then transformed into other chemical entities, probably. It has to be transported, and then in the end, it has to be being used. You have to know that the transport of hydrogen as such, as a gas, is only possible over rather short distances of very few thousand kilometers. If you go any further, then you have either to do this as liquefied hydrogen, is also not that easy to do at very low temperatures, or you have to do a transformation of hydrogen to other chemical species, which is being discussed these days very heavily. And of course, South America and also Argentina are seen as being prime sites for the production of hydrogen, as you all know, due to the availability of wind sites, for example, in southern Patagonia, but also in photovoltaic sites in other areas. And I think that will have a major impact on industry and research also in this part of the world. Recently, we know that the German Chancellor was in Argentina to discuss an even closer partnership a few weeks ago. However, it's also very clear that this issue is not that simple. People in the area concerned are worried that their environment will be just sacrificed for the energy industry in Europe, and therefore it's of importance that we keep their interests also in mind, and that the green economy does not turn in an exploitation, for example, of the local people in these regions involved. But let us come back to the real question of my talk, the scientific collaboration. And again, as for COVID, you can see that a huge number of papers are now being issued in different sides of the world on these kind of issues. The collaboration is extremely strong in the whole field of environmental sciences. And indeed, it is true that it includes all the major industrial states these days. So industrial scientific collaboration, that is my first message, is essential for solving big challenges we are facing these days. Now the question is, of course, who collaborates? And if you look for the statistics, what are the hotspots of scientific excellence, and what is their international collaboration pattern? And this figure shows you now, the first figure shows you now, these are the 10 top sites in the world which produce science these days. You can go to statistics, you can go, for example, to the Science and Nature magazines, you can look at the Nature the Nature list of the most highly cited papers, let me say, not only in Nature and Sciences, but in all the major journals as such. And then you can see these are the top sites which come out. These are 10 sites. The majority lies in the US, Harvard, MIT, Yale, Columbia, Stanford, Caltech, Berkeley. In Europe, you have two sites, the Max Planck Society, which, by the way, ranks number 3 in this whole list, in Cambridge, and we have the Chinese Academy of Sciences. If you look for the top 3, by the way, the Chinese are the number 1 these days, which is quite remarkable. Then we have Harvard, and third is, as I said before, Max Planck. Now the next view gives you, the next diagram shows you a little bit a closer collaboration scheme as we have it for the Max Planck Society. These are, of course, the best data I have in my folder. but the other ones are very much similar. First of all, you can see that the collaboration of the Max Planck Society is 2/3 international and 1/3 only national. So the majority, the vast majority of scientific publications which are being issued by the Max Planck Society are international collaborations. And if you look now on the list of the most important, let me say, collaborating partners worldwide, then it starts, and you only should focus on the not on the blue part, but on the pink part or so. The first and most important collaboration partner is the French CNRS. The second one is Harvard. Then we have Oxford, and of course we also have the Chinese Academy of Sciences. And if you look, let me say, in the other statistics of the other sites I mentioned here before, you would get pretty much the same results, with the exception, by the way, of the Chinese Academy of Sciences. There the collaboration is by vast only internal in China, and only a small part is international. So what does it mean? It really means that the collaboration in sciences, this huge part, is among these top 10 sites in the world. That's a network, let me say, which comes up with this kind of international collaboration. The next question I would like to discuss is, where do the people come from that work in those sites? And then you can see, of course, these are not only the national people living there, these sites attract people from all over the world. And again, this is a statistic I have for the Max Planck Society, where I have the best numbers available. You can see that even on the directors level, we hire now 40%, no, we hire 2/3 at the moment from outside Germany. So if you take, it's a total number of directors, 40% of our directors now don't have a German passport anymore. And the same is true for the other ranks, let me say, group leaders, postdoc students. You see the numbers. The vast majority is international in the Max Planck Society, and no longer German. If you look for the statistics, where do these people come from in the Max Planck Society? I'm now looking for the junior scientists, because that's the largest number we have. Then you roughly can see that 1/3 of them originate from Europe. 25, so 1/4 originates from China and India. 15% from the United States, and I have to say Argentina on that list is not that much present, and that is something we should change also in future. I have some more detailed numbers for South America in particular. These are the number of researchers in the Max Planck Society from South America. So in average it has increased. In average we have about 700 researchers now from Latin America working in our institutes. Now if you look in detail what has happened over the last 10 years, where these people come from, then the next statistics gives you an idea what has changed between 2013 and 2021. I find this quite remarkable, by the way. You see the green part, the shiny part, is the latest numbers, 2021. In some states, it has increased dramatically. You see Brazil, for example, has increased from 40 10 years ago to nearly 200 now. Chile has had a rise which is quite remarkable, and to my surprise, also Colombia, Mexico have an enormous rise in students, let me say, which now work with us. All these students, by the way, are chosen by excellence. It's not that we just take people, let me say, because they just apply. They all have been selected according to very severe mechanisms. So obviously, science has also grown up in these states. Also, Argentina has growing numbers, but if you compare this with the other ones, I think there's some room to grow. I think Argentina could be stronger, as we can see here. The question now is, and that is one of the major parts I want to talk about today, what is the impact these people have on innovation? Not only on science. I think science, we publish science, I've told you before, but on innovation, which is very much coupled with science. And for this, I would like to give you a kind of few slides only, kind of idea how important basic science these days is for innovation processes. Now, the best data I have from Europe, and I find this totally surprising. In Europe, we have a scheme which is called the ERC, the European Research Council, and the ERC grants, the grants from the European Research Council, are now being seen as one of the highest ranked grants you can get in Europe as such. So it gives you good statistics, because many thousand grants have been handed out over the years. And here you see on this kind of table, which is not as colored as I thought, but it's I think you can still see this, that these are the sites, let me say, where most of the ERC grantees do live. And honestly, if you get an ERC grant, you can go to any site you would like to do your science. You can just can take your grant and go there. You can see the density is very high in the southern part of Britain. This is, of course, Oxford, Cambridge, London. It's very high in Paris. Paris a little bit a special role because of CNS in Paris, so I think they count all the CNS awards to Paris, which may not reflect the real truth. You see a lot in the southern part of Germany, including Switzerland. You see a lot in the Benelux area, again, very much attached to Germany. And you don't see any of these dots in the eastern part, middle eastern part of Europe. So it's a deep gradient, let me say, in scientific excellence in Europe, as you can see here. Now, the most interesting part is now if you combine this data with the scientific excellence with the innovation strengths. And that's what I wanted to tell you. The innovation strength is also well thought through in Europe. There are good statistics how innovative certain regions really are. And if you plot this now down, and I have to say the darkest green represents the most innovative regions in Europe, and the brown part the least ones, then you can see a remarkable, kind of remarkable overlay between the areas where you really have innovation and those areas where you have excellence. There is indeed a coincidence between excellence in science and innovation, and that you could see, by the way, for many other parts of the world. That is trouble for many regions in Europe which are not good in science and neither good in innovation. So there is a kind of gap between, let me say, the leading regions in Europe and the other ones which are lagging behind. This also, to the same result, you can come in a recent paper which has been published only last year, which in fact tries to link the ERC grants with patents, which do cite the result of these grants which have been funded before. And first of all, you can see there's a time lag between, let me say, the grant, the ERC grant which has been given out, and the papers which have been originated from these grants, and the patents which start to cite these grants. So the time delay is probably about 3 or 4 years in general. But you can also see that more than 40% of the ERC grants which have been issued have, in the end, ended up in patents which have been cited. Now, I could go much deeper here. You can also see these are high-quality patents, not just patents which also have proven to be highly successful. So there is an enormous link between the excellence in science, patents, and innovation. And you see here the fields where these patents have been issued in biotechnology, pharmaceutics, computer science. You can see this as easy being written up here. Obviously, what I always have said is what we need, and that is something I would like to get over also today, we need what I would call low-risk sites for high-risk business. Low-risk sites for high-risk business. What does that mean? Low-risk sites means there is no risk there because you have the brains there. For business, which is in fact risky, starting something totally novel is risky. And if you want to minimize this risk, then you have to go to those sites where you have the brains which may do the work rather successfully. Now, that means also the researchers, the international researchers I mentioned before, have a major impact on the innovation processes where they are, even if they come from Argentina or any other site. And here you can see the statistics, again, a recent paper which I found, and just mark, I would like to read the yellow part. The only moderate increase in patent application developed in Germany over the last 10 years is exclusively due to inventors with foreign roots, which you can easily see because you can check at the patents, you can see where they come from, so you get this correlation. The same is true, and you can see this now scaled down to the different organizations. Max Planck is in red here. So 1/4 of the patents which we do in Max Planck these days is from inventors with foreign roots, which of course stay with us as postdocs, as scientists, as directors. So there is the brain gain which we have, let me say, in these sites has a major impact also on the innovation processes. And this is the last part I wanted to show you here, and that explains all of this. You see that patents which are now being filed to a large extent now depend on federally subsidized research being done in the same state. You can see this for the US here. It's a paper which has been issued for the US. You see for many years, let me say up to 75, only a very small fraction of the patents which have been filed had any relation to, let me say, research being done in the public space, universities, etc. Now it's 1/3. So 1/3 of the patents which are being filed strongly are based on, let me say, research being done in research institutions, in universities, etc. And that means if you do not invest in these structures, if you do not invest, let me say, in research activities, in universities, research sites, probably you end up short in the patterns as you see here. And then there is, of course, the question, how much do we invest, indeed, in research and development? And this is a kind of hit list which you may be all aware of. What is a fraction of GDP you invest in research and development? You see there are few countries like Israel or Korea which really stand out. They invest between 4 and 5% of their GDP in R&D. Germany is doing pretty fine, has a number of, I think, 3 point something. But if you look at Argentina, it's only 0.5%. So there is a misgap between what the states can do, in fact, in research and development. You also have to understand, if you read these numbers, that for the industrialized states like Germany, 2/3 of this investment is not by the state, but by industry, and 1/3 is by the state. So the 3% comes down to 1% by the state and 2% which is being invested by the industry involved. But it's obvious, if you put all this together, that brain gain and brain drain has a significant consequence, for the local economies. So strong countries, I think that what I showed you before, profit, they benefit, the weak ones lose. That's what happens in the world these days, and that is one of the problems we are facing in the world, that the gap between the ones who can do it and the ones who are not on the forefront gets larger. The reason is very simple. These days economy, these days industry is a knowledge-based industry, and you do not have the knowledge if you don't have the universities, if you don't have the people who do so, you're ill off, let me say, in the end. And you may have natural resources, but you don't benefit from these natural resources because in the end, you don't build the industry based on this. The question, therefore, is how can we speed up brain circulation? I've talked about before on brain drain and brain gain, but what about brain circulation? What we really have to have, so make a circle out of the whole thing and not just take people from here to there and have an advantage out of this. And there's an interesting statistics. Sorry that this is a very complex picture, which you have to look at a bit more in detail, probably more time than I have right now. This gives you, this picture concentrates on those scholars who have moved from one continent to another between 2008 and 2015, so in over seven years. So, for example, people who have stayed in their continent, Americans who stayed in America, are not counted here. Only those who are, let me say, have switched the continent from A to B, which is being seen again by detailed paper analysis. You can see, for example, the Europeans, which in 2018 have been in Europe. They, to a large extent, go to North America, as we all know. Same is true for Asian people. Asian people, to a large extent, go to North America. People from North America who have stayed in North America in 2008 end up in Europe or Asia again in 2015. This is brain circulation. These are the ones who have been going to the US and then return to their home states. That's what we do in Europe, that we do in Asia. And this is a part of brain circulation which you can see from these kind of statistics. But in the end, if you put all this together, the US is a big winner in this whole game. And they gain 50%, by the way, in this kind of statistics, whereas the other do loses. But there is also a significant fraction of brain circulation ongoing. Now, what do we have to do in order to foster brain circulation? And I have only very few slides on this here. But of course, first of all, I think the receiving country must have kind of absorption capacity. So if you bring somebody from here, I don't know, to Europe or to the US, and you want to bring that person back to here, there must have been some absorption capacity. There must be some position. There must be some position you can have a living on for the time being. Otherwise, I think it will not work. That means you have to have attractive sites, as otherwise coming home from the US will be very, very difficult. So to make sure that the sites are attractive, the universities are attractive, I think is a must. Second, of course, there are sometimes specific infrastructures. I have just put here the Atacama and the observatories we have there. There's, of course, the best observatories in the world these days are in Chile, in the Atacama. I had to visit them a few years ago. Remarkable instrumentation, better than what the US has. And that has also steered up, let me say, astrophysicists steered up astrophysics in Chile, for example, because also Chileans are working there. And so the universities doing astrophysics are quite good, I have to say, based on, let me say, the infrastructure which is there. Infrastructure may also mean, for example, natural resources, which you also have here, like lithium. in South America. It's a natural resource where people can build upon, and I think these resources should just not be sold to somewhere else as a natural resource, but also should be the nucleus, let me say, of science which is established here. And of course, there are certain programs that I also have to mention, programs which want really to foster brain circulation. And these funding processes do happen, for example, in Europe. In Europe, we have indeed a line which we call widening, which is indeed directly aiming to do brain circulation, to build up, let me say, research sites in the eastern part of Europe, for example, which you have seen before is not that efficient these days. Even the Max Planck Society is quite active here, I have to say so. This is a program I have initiated by myself. We call it Dioscuri. Dioscuri is the Greek name for twins. And that's a program which is at the moment focused to Poland and also Czech Republic, but we want to expand this. It's being financed by the German Federal Ministry of Research and Education. What it really means is we want to make sure that people, in fact Polish people which live abroad in Cambridge, in Oxford, want to go home to Poland to build up their own group there. Now, how do they do this? They do this because they get a certain grant, but money is not enough, that I can tell you, because they get also grants in the US if they stay there. I think it's also that we back it up as a Max Planck Society, that we say, okay, you are a part of us. You can team up with us. You can make a collaboration with us. We give you, let me say, a group of international leading scientists who accompany you in that progress of establishing that small group. And I have to say it's highly successful. We have many, many applications from all over the world, mainly people who originate from these countries who want to go back. It also means that I also have to say that the structure in these universities changes so that it's promising for young international people to be there. So if we have very old and ugly structures like we used to have them in the eastern part, like this Academy of Sciences, average age 80 or so, then of course nobody wants to be there. So it has also to mean that one has to change the structure of the receiving unit to make it more attractive. Latin America, my last topic in the Max Planck Society, is something we always have been interested in. Here you give some kind of timeline. I think according to the best of my knowledge, the first deep interaction between Latin America and the Max Planck Society came up when Thomas Jobin was the first Argentinian researcher who became a director of the Max Planck Society. And from that moment on, he also, of course, made sure that, let me say, the relation between Argentina and the Max Planck Society got better and better. I still remember Silvia Braslavsky, who was a research group leader in our Max Planck Institute in Düsseldorf, and she also had a very strong impact on what is going on here at the university, for example. We have the new institute being established, the Biomedical Research Institute in Buenos Aires, which is a partner of the Max Planck Society and has a major impact, let me say, in this field, let me say, on this kind of collaboration between them and us. And of course, we have had a Max Planck liaison office. We had conferences here. Many directors came up here. That's something we also want to continue in future. I myself, by the way, had many visits to Argentina. I think the 90s, the first one, I will end with this in a minute, was in 1992. Oh, sorry. Yeah. These are the number of programs we have at the moment between us, Max Planck Society, and Latin America. So we have a number of what we call partner groups, tandem groups, special groups, which have a link between their home institution here in America and Latin America. And as you see where they're situated, and you see that Buenos Aires is a major hub here, I have to say. The tandem groups is of special importance. Here you see how they have been growing over the years. And again, you can see that in some parts, I think, let me just see. In some parts, the growth was quite remarkable. Again, I have to say that if you look at these numbers in detail, Argentina could do better. Other states are at the moment at the forefront, and Argentina is a bit lagging behind, which I personally find very unfortunate. Here you see I think that's my last slide in this context, is the relation we have between the Max Planck Society and Argentina. If you just look at the numbers being published, at the moment I have to say the CONICET ranks number 3 in the international collaborations numbers which we only have seen between in Spain and France. So we do have, in fact, a deep collaboration with Argentina at many sites. And of course, there are prime institutions. I mentioned already the CONICET Max Planck Partner Institute for Biomedicine in Buenos Aires. I mentioned the APEX observatories. We have the ATO Tower in Brazil, which is one of the hotspots where we do interact. So many of these things indeed ongoing. Yeah, and there have been many events I mentioned here in Argentina even recently. Now let me finish my talk with a kind of private experience I had with Argentina. And this is a short video I want to show you, which started in 1992 when I had my first video camera. And I visited Ernesto at that time, so it's really 30 years ago. And it's only a short sequence, I have to say, out of this video. It's a lengthy video, otherwise it would be too boring. And Ernesto showed me at that time the university. So you see here how we start. I think the same building still there, I just saw it. The big entrance door. And I hope the tone is coming later. And so he wanted to show me, let me say, his group, his activities. He also showed me a bit of the country, which is, of course, quite remarkable. And you will see this in a minute. That's the floor. His office and his students have been there. And this is one of the students. That's me 30 years ago. Yeah, that's Ernesto, how we know him in his office. A bit disorganized, as I said, 30 years ago.
The resort place in Mar del Plata, Bariloche, Tierra del Fuego. We are here.
So you thought I'm ignorant, of course.
Mendoza, the mountains, Salta, where Professor Schulze has been.
You know, he wanted to show me some nice sites in Argentina to make sure that I come back. One of his students, Ernesto Vago, he mentioned him before. That's part of the instrumentation, by the way, we chaired at that time, which also came from GTZ. It's soon over. Yeah, in addition, of course, it's not only the science, which I found interesting at that time. It was a landscape. This is the Delta, as you all know. So we had many tours in these days, riverboat tours in the Delta. Quite remarkable. I'm not sure how it's looking today. That was a site 30 years ago, more or less. Yeah, and of course, in the evening, you had to do some barbecue with Ernesto in his home, which I also find always extraordinary. You see, I'm a fan of Argentina, honestly. I like to be here many times before. I enjoyed the collaboration with Ernesto, with the whole group, and with Argentina as such, and also as president of the Max Planck Society. I'm very eager, let me say, to make sure that this collaboration, this intense collaboration, will also extend in the future. I can only wish all the best to Argentina. I can also wish all the best to Argentinian scientists. I think my conclusion for this talk is you have to invest in science. If you do not invest in science these days, I don't think you will make it as a country. And we all know that those states who only live from natural resources is not a good living for the majority of the people. The majority of people need industry and not just natural resources. That's good for a few, but not for the majority. And I only can hope you can build on a really good standing. You can build on a university which is a high-ranking university worldwide. You can build, I can really say this, on people which are trained here, which are exceptional. And I think you have to fight the brain drain and to come to more kind of circular conditions. And I would support this as much as I can. So thank you very, very much.
A continuación, hacen entrega del diploma y de la medalla que acreditan Cristina Martí Stratmann como doctor honoris causa de la Universidad de Buenos Aires. El rector, doctor Ricardo Gelpi, y la vicedecana de la facultad, doctora Valeria Levy.
Dear Rector of the Buenos Aires University, Professor Ricardo Gelpi, dear Dean, Deputy Dean of the School of Exact and Natural Sciences, Professor Valeria Levy, I really feel honored, I have to say so, I really feel deeply honored for having received the Dr. Honoris Causa from this very highly respected university, which is indeed one of the best universities of the Spanish world. And I'm really proud of this honor as it reflects also the very many years of close collaboration between my scientific group in Düsseldorf and the corresponding activities in electrochemistry here in Buenos Aires. I would like to thank my good friend Ernesto Calvo for his nice words, and I would like to thank everybody who has proposed me for this very outstanding honor here today. I also have to say I received this honor also as president of the Max Planck Society, and it reflects the deep collaboration between the Max Planck Society as such and Argentinian scientists in the university, also beyond the university, for the very, very many years. I'm pretty sure that we will continue this deep collaboration also in the years to come for the benefit of all of us. And for that, I would like to give a very small present to you as rector of the university, as president of the Max Planck Society.
Oh, please. Thank you very much. Thank you very much.
And same for you.
Thank you.
Thank you very much. Thank you. I will do so.
Thank you so much.
Oh, it's a pleasure to be here.
Yeah.
And it's a great honor for me.